This is the MHF4U Unit 5 seminar on trigonometric graphs. So we are going to break down the transformation equation today, analyze amplitude, period, phase shift for the different graphs, and really examine mapping relationships. That's what it all boils down to when you're graphing. You have to really understand how to do mapping relationships. This is the cosine, cos x function. You don't have to graph the whole thing in your notes. However, it is important that you know what the key points of the cosine function are. So I'm going to write them down right now. At 0, you notice we're starting at a maximum point. So my first point, 5 key points of the cosine function, which you're always going to apply your mapping relationships to. First point, 0, 1. Second key point, pi over 2 and 0. Third key point, pi negative 1. Notice at pi we have our minimum point. At 0 we have our maximum point. Our fourth key point, 3 pi over 2, 0. And our final key point is 2 pi positive 1. Those are the key points of the cosine function that we're going to be applying all mapping relationships within. And notice, to go from this maximum point to this maximum point, complete one cycle from 0 to 2 pi. That's why when we're calculating our period, one complete cycle is always 2 pi over k, because it takes 2 pi for the parent function to complete one full cycle. The same thing is true for the sine function, not the tan function, and we're going to look at that in a bit. So I want you to copy down the bottom note as well, in addition to the key points. The zeros of y is equal to cos theta occurs when cos theta has a maximum value of 1 and a minimum value of 1 at. So we know our maximum value occurs at 0, value of 1 at 0, as well as 2 pi. And a minimum value of negative 1 happens at 3 pi over 2. That's the criteria for the cosine function. Now we have to do the same thing for the sine function. This is a much more detailed graph, but if I'm looking at my 5, I don't expect you to memorize all those degree measures, all those radians. Really, I'm looking at my minimum point, my maximum point, back to my minimum, which we also call the zeros, or the roots of the sine-cosine function. These are the 5 key points that I'm looking for. So when I'm talking about y is equal to sine x and you're applying mapping relationships, first 0, 0, then pi over 2 has a maximum value at 1, that's at 90 degrees. Then at pi I have another x-intercept, another 0. 3 pi over 2 has a minimum value of negative 1. And at 2 pi and back to my x-axis, I have another 0. Those are my 5 key points. So the zeros of y is equal to sine theta. The zeros are basically multiples of pi. We notice at pi we have an x-intercept. At 2 pi we have an x-intercept. At 3 pi we'll have another x-intercept. So multiples of pi, we're going to have our x-intercepts. Sine theta has a maximum value of 1 at pi over 2 and a minimum value of negative 1 at 3 pi over 2, and all angles coterminal with them. That means all related angles. So 90 degrees, we add a pi to that, you're going to get another maximum value. Add pi to 3 pi over 2, you're going to get another minimum value. So all angles coterminal with them. And because we have 5 key points, remember when we're attacking our word problems, that's why we divide our graph into 4 key areas, because when you have those 5 intercepts, notice from 0 to the maximum is one part of the graph, then from my maximum to the minimum is another part of my graph, then from my from my x-intercept to my minimum, third part of the graph, and from my minimum to my next x-intercept, 4 parts to the sine function, okay? Word problems, we always divide our intervals into intervals of 4 to figure out where all the x-intercepts and the maximum minimum values are going to take place. Okay, we looked at related angles, principal angles, and all of that are key in determining the different points on the sine and cosine function curve. That was from the Unit 5 seminar. Now this chart is really important because it analyzes when you are given an equation and your k term has not been factored out. Remember, you cannot determine the correct phase shift unless your k term is taken out of the bracket and that p term, or whatever is inside the bracket, is divided by your k term. So always make sure sine and cosine functions and tan functions are in factored form, because you have to analyze, or you won't be able to analyze the correct transformations and the period without factoring your equation first. We're going to look at specific examples. Also, the order of applying transformations are really, really important, the order. So horizontal, vertical stretches and compressions always take place first, along with reflections, because those are transformations that we multiply when we're doing mapping relationships. Phase shifts and vertical translations are the last type of transformation that we do, because that's adding or subtracting from our x-intercepts, not multiplying, our x and y coordinates of our key points, okay? So pay special attention to the order of transformations, not order of operations, order of transformations. So here's an example of the cosine function. We are going to analyze this, copy this down into your notes. We're going to analyze the amplitude, period, phase shift, and we're going to figure out what the mapping relationship is so that we can apply the mapping relationship to our key points and graph this function. Now, notice beside the question, they're stipulating a range. So if you got this on a test, you would be expected to draw your graph from negative 4 pi to positive 4 pi, not just 0 to 2 pi or negative 2 pi to positive 2 pi. They're specifying exactly the range that they want you to draw the graph. And I have already sketched the graph for you so we can compare, but first things first. So, can someone tell me, is this equation in factored form? In my transformation equation form, what do I need to do?
Factor out the 1/2 x.
Exactly. Not the x, but just I have to take that 1/2 out. Whatever is in front of the x, I have to divide it out. So my 4 cosine, notice that I'm dividing both the x term and pi over 2 by 1/2. I'm dividing both of those values. So you're left with 1/2 divided by 1/2 x is just x by itself, and pi over 2 divided by 2 is going to leave you with a positive pi. And then I still have my vertical transformation of negative 1. Okay, so the amplitude, which is also equivalent to vertical stretch in this case, my amplitude is my A term. So my amplitude is going to be equal to 4. Remember from last year that period is how long it takes to complete one full cycle. And my formula for period is 2 pi over